Hi, everybody out there across the world. Welcome to my webinar on the new E911 geolocation support in Asterisk. Before we get started, I just wanted to say that joining us on here, we have Mike White for all of your salesy type questions, since it is highly unlikely that I would be able to answer anything related to sales. However, usually we also have Lauren joining us. He's not able to make it today. However, if you have any questions regarding free PBX, feel free to submit those and we will forward them on over to Lauren for answering. So with that, let's get started. My name is Joshua Culp. I am the Asterisk project lead, which is just a way of saying that I make sure Asterisk is pointed in the generally correct direction when it comes to development. So throughout this webinar, I'm going to be talking about 911, and this can really be referred to as a placeholder for how to contact emergency services. I know in other locations and countries, there may be other numbers, but throughout this, since I myself am in Canada, I refer to this as 911. So in the beginning, and still for many, we have address information per DID. So each user or endpoint has a unique DID, and then ahead of time, we configure with our upstream provider using a portal or an API some address information associated with that DID. For calls placed to 911, we then have to ensure that our caller ID information is using the correct configured DID, so that the emergency services are able to receive the correct address information. And then for cases where no DID is assigned to a user or endpoint, a general one is commonly used, such as a general one for a business, a number that might go to the reception desk, something like that. This inherently, however, does have some problems with it. So you need the complete information needs to be configured ahead of time, and isn't easily changeable. And in many cases, you can't really include more specific location information like floor, room, etc. And then the really big case is for mobile clients, ones that roam around. So in those cases, you can only present pre-configured home address information or course physical location. You might see this if you are registering your mobile phone with your cellular provider for Wi-Fi calling at home, where you actually have to fill out E911 information for your home. So a solution appears, E911 geolocation. But what is it really? And so E911 geolocation is really the combination of existing RFCs and standards. And when I mean standards, I'm talking about stuff, for example, from the 3G PPP group, not just SIP standards. And these were all brought together to allow the transport of geolocation information to an upstream carrier. And from a technical level, this boils down to some XML. XML, everyone loves XML, not really. And also some SIP headers. And this allows location, not just address information, to be dynamically sent for each emergency services call. However, there are cases where you don't need that level of dynamic setting of the location information, so it does also provide the facility for doing statically configured as well. And by having this on each call to emergency services, it means that you don't need a specific DID per user and endpoint. And you might have noticed that I referred to this as location and not strictly address. And this is because location covers more than that. It can certainly cover address, such as street address with floor and suite, floor, suite, and office, hotel room, but as well GPS coordinates, and even more than that. So location can be extremely specific in comparison to just an address. Now, a few words on the RFCs and standards. Like I said, these were existing RFCs and standards put together to facilitate this. That means that they weren't originally written with emergency services in mind. The consequence of this is that not all aspects of the RFCs and standards are actually applicable or relevant to emergency services. A really good example of this is that within the standards and specs, you can technically convey an unlimited number of locations on a single call. So the spec says you could theoretically provide an address in New York and an address in Los Angeles on a single call. It doesn't really make sense, but the specs allow it. However, in practice, providers are really only accepting one location information. And so a consequence of that for our implementation is we followed that. And so we currently only allow you to set a single location information for an outgoing call. If this changes in the future, for example, then we can easily adapt Asterisk to comply with that as needed. And sort of a running comment or joke I've had throughout this work being done by my colleague George, who is probably listening, hi George, is that I expected the Asterisk project to probably become the definitive source of information for all of this work. And that's because no one had really taken the time to go through all of the RFCs and standards that were referenced and actually make a list. So on the Asterisk wiki, under geolocation reference information, you'll find a complete list of all the RFCs and standards which are relevant to this work. So if you're curious about those details, I highly suggest going through that list and taking a look. So the geolocation work actually provides two mechanisms that you can provide information. One is called pass by value, and the other is called pass by reference. We're going to start by talking about pass by value. Pass by value, as you might expect, provides the complete location information within the call, and this is done using XML. So the RFCs do include XML specifications for this and what it looks like. However, on an invite, normally you just have SDP. However, we also need to attach that XML location information. So for the invite to an upstream provider, we actually do that using something called Multipart. Multipart is not often seen in SIP, but it is supported by Asterisk as a platform as well as many others. And it allows you to attach multiple content types to a message. So in this case, it would be a content type of XML and a content type of SDP. As the name might suggest, each content type is added as a part, and thus the name Multipart. So like I said, for geolocation, one part's XML, other is SDP that you already know about. Something to note, we don't send Multipart on every call, just when sending the XML information as well. So if you're just doing normal calls, you're not going to see Multipart. However, those in the audience who have dealt with XML might think, gee, XML can get pretty big. And you would be correct. So this can potentially bring about a problem with things. The addition of XML alongside SDP can cause the SIP invite to become quite large enough that it may actually exceed the maximum safe size for UDP. So when talking to upstream providers, they may require you to use TCP or TLS. You may fundamentally, however, want to use TLS if you're passing by value, since you're putting specific location information within that invite, which can identify where a person is. So you may want to go the extra length and use TLS if possible to protect that information. The other aspect is passing by reference. And this actually has two aspects, and we'll start with static. So this is what we pretty much use to a degree these days. You configure ahead of time the actual location information with an upstream provider, and they give you this unique reference token. This token goes into the outgoing SIP invite in a SIP header. And in this case, you don't need to put any XML in the invite, so the invite can remain relatively small. And the upstream provider can use this token to find your pre-configured location information that is stored with them and send it along. In comparison to the case where you configure per DID, this, you don't have to do it per DID. However, because you're passing that reference, it does allow you to give that more specific location information. And like I said, the resulting SIP invite nowhere near as large as if you were doing pass by value. The other aspect supported by some providers is doing this dynamically. So the geolocation SIP header that is given to the provider can actually contain a URL. If you pass a URL that points to you in some capacity that contains the XML document for the location information, your provider, if supported, can retrieve that information and use it instead. This means you don't have to stick that XML in your invite and increase the size of the invite. Because it's a normal HTTP request, you can generate that dynamically if you wish, say from a customer database, or you can pre-generate them instead. And just like the previous pass-by reference, this doesn't require a DID per user or endpoint, but still does allow that more specific location information. And I keep hammering this home because packet size is a huge problem in SIP. It's just seemingly grown larger and larger over time, but thanks to this, the SIP invite is nowhere near as large as a dynamic location using pass by value. So providers, none of this really works if providers don't implement and support it. To that end, not all currently support the RFCs and standards for geolocation, and some of them even may want things formatted in a certain way that may differ from another provider. Some also may not allow you to have all aspects of the location be dynamic. They may only allow adding what is called second address level information, such as suite, floor, hotel room. I'm aware of at least one provider that requires you to pre-configure your street address, and then you're able to add the suite, floor, and hotel room within the call to 911. As always, you must read documents, you must talk to your providers, and you must do interop testing. This is not something that you just implement and don't talk to your provider about. It's a back and forth relationship that you actually need to do. This is emergency services. It has to be taken seriously. So how does Asterisk fit in with all of this? So Asterisk now has geolocation support within the core and with PJSIP. It is not supported within ChanSIP, which I hope is not a surprise to anyone. I will also take this opportunity to state that ChanSIP has been removed from Asterisk Master, which means it will not be present in Asterisk 21. So as always, when doing presentations like this, I always state PJSIP is the path forward, upgrade to it if you can, or make a plan to. So location information can be configured ahead of time using normal configuration files, or you can generate it in the Dialplan. Asterisk takes care of all of the XML heavy lifting. So that's serializing and deserializing the XML. The multi-part stuff, of course, we take care of automatically as well. And we don't just support sending of geolocation information, we also support receiving it. So conceptually, a phone, if it wanted, could send geolocation information to Asterisk, and if we were configured to do so, we could pass that on. The core functionality is held in the res geolocation module. This provides the configuration aspect, core functionality, and also some Dialplan functionality. It's configured using the geolocation.conf configuration file, and fundamentally it has two concepts, locations and profiles. Location, as you might expect, is for configuring all of the location information, and profile is really about telling Asterisk how that location information should be used. So if we should accept reception of it, if we should send it out, how the formatting works, and how we should merge things together if we receive it on one end and we have configured information. So the location configuration type. This is what configures the actual location information according to the specifications. You must consult the specification for how to specify things. It dictates a specific way that things are to be formatted. Multiple location information options can be specified. Method option specifies how the location information was determined. Source is where the location information came from. Confidence, as you would expect, is how confident you are in that information. And a nice thing is that these do allow channel variables to be referenced. So you can stick some call time information within channel variables and just have it substituted into your pre-configured information. Now, an important aspect is that Asterisk does not validate the location information provided. We just take it as is and we will pass it upstream as is. So it is up to you to ensure that it is correct. As well as always, I do urge people to check out the Asterisk wiki. So further information is on the wiki under geolocation. Search for geolocation and you should find it. The profile configuration type. So profile precedence option specifies what to do with location information. PIDF element, this is something we found out through testing with different providers, is that they may want the XML formatted slightly differently. So we provide an option to allow configuring that. Allow routing use, alters the value of the geolocation routing SIP header. Location reference configures what location to use for the profile. And location info refinement allows you to further refine that referenced location. A good example is you might have a location for your office, which is just your street address. And then in a profile for a phone, you might, using local location info refinement, add in their floor and office number. As well, there are more configuration options, so do consult the wiki and the sample configuration. We also provide a Dialplan function because some people want to do things in a dynamic manner. So this allows the manipulation of the settings at call time instead of having it pre-configured. So you can set profile settings, you can set location information, and ultimately it allows you to set a minimal amount of configuration within the geolocation.conf configuration file. A nice benefit of this is that you can actually query from the Dialplan, for example, using funcodbc, a database at the call time to retrieve location information and use it there instead of having to configure the .conf file. So for those who like doing things dynamically, this is the way to do it. Chan PJSIP usage is relatively simple and easy. So we have one option called geolock, incoming call profile. Geolock means geolocation, of course. Specifies the profile to use for incoming calls. So in this case, incoming calls means a call from the endpoint to Asterisk. Geolocation outgoing call profile specifies the profile to use for outgoing calls. So those are calls from Asterisk to the endpoint. In the outgoing case, that would commonly be your upstream provider. And then all further configuration is done just using the geolocation.conf configuration file or the Dialplan function. So within PJSIP, we just have those two options to specify which profile to use. The PJSIP geolocation module is what actually takes care of handling the geolocation in PJSIP from a SIP perspective. So it's what's handling the XML portion, reading it in from the invite or adding it to an outgoing invite. And it also takes care of the SIP headers for geolocation. And there is no direct configuration of this. You just load it and it works according to the profiles that are configured. So let's put this all together. You configure location information using location type in geolocation.conf. You configure a profile using the profile type in geolocation.conf, which references the previous location, and then you configure the geolocation outgoing call profile option on the upstream provider PDSIP endpoint with the profile. You send the call to the provider, and Asterisk takes care of the rest. Something to note here is that Asterisk has no concept of what is and is not an emergency call. So in cases where you don't want to actually have your location information sent to the provider, such as if it's on a regular call, then you can use the Dialplan function to turn that off for the call. Or you can do the vice versa and turn it on if you're calling emergency services. That's really up to you. So that is geolocation and 911 support in Asterisk. It is in Asterisk 18 and 20 as of right now. So you are free to use this if you wish. I do realize I probably went fairly fast. But one of the things about geolocation, E911 stuff is that this is stuff you need to take seriously, and you need to put in the time to read our documentation and understand it. This webinar will not cover things to that degree, but does give you a nice higher level view of how it works within Asterisk.